Welcome to BTEC Revision. In today's lesson, we're looking at sinusoidal waveforms. By the end, we should be able to calculate the time period, frequency, root mean square value, and form factors, and compare sinusoidal waveforms to non-sinusoidal waveforms. What is a sinusoidal waveform? A sinusoidal waveform, often simply called a sine wave, is a smooth, periodic oscillation that represents a mathematical function called a sine function. Sinusoidal waveforms make accurate representations of voltage and current since they are varying, and the variation matches that of a sinusoidal wave. Voltage and current vary, and it matches the sinusoidal waveform. So we can use the sinusoidal waveform to represent current and voltage. We need to be able to label the sinusoidal waveform. Here we have a sinusoidal waveform, and the maximum value is known as the peak. Next, we can look at something called peak to peak. This is the distance that is maximum from the top to the maximum value at the bottom. Next, we can look at something called the wavelength, which is the distance between two consecutive points. For example, if we take 2 points at the bottom, that distance is called the wavelength. The wavelength can also be found from any 2 consecutive points. For example, at the top here, and even in the center. Each wavelength represents one wave. Looking at the diagram, there are 4 waves. We can also draw this wave on a graph, like so. This would help us to see all the points a little bit clearer. Plotting this wave on a graph, now we can set this wave in motion, and we can count the time period. We can choose any point. Let's choose this point over here. Let's call it point A. And as soon as one wave passes that point, so that would be over here. So this position, we'll look at this position and count the time it takes for it to reach point A. That would be the time period. So let's start. So that was about 2 seconds. You can try that again. 2 seconds. So the time period for this example, t equals 2 seconds. Next, we can work out the frequency of this wave, and it is the number of waves every second. So we'll choose point A again, and we'll use that as reference. And instead of doing 1 second, we can do 5 seconds because it will enable us to work out a good value. And if we divide the answer by 5, that will give us the number of waves per second. So let's start. 1, 2.5. So we can write down the frequency, which is 2.5 waves, but we got a time of 5 seconds. So we'll divide that by 5. And if you work this out, this gives us a value of 0.5 seconds to the power of -1, because this is the number of waves per second. Another unit we can use for frequency is something called hertz. So we write that as H-E-R-T-Z and H, capital H, lowercase z for short. Our values that we got, time period is 2 seconds, and our frequency was 0.5, and the unit is hertz. Now, let's take a look at how they are related, which is via this equation. The frequency is equal to 1 over the time period, or F equals 1 over t for short. Time period is measured in seconds, and frequency is measured in hertz. Now, let's take a look and see if our example before was counted correctly. So the time period is 1 over frequency, and we got a frequency of 0.5 hertz, so that's 1 over 0.5. And that's equal to 2 seconds, which is matching our time period that we counted. Now, let's take a look at this example. Calculate the frequency of a wave when the time period is 10 seconds. We can start by writing down our equation. Time period is 1 over frequency. Now we can rearrange, so we can swap f with t to give us f equals 1 over time period, and that's equal to 1 over 10 seconds. And the value for that is 0.1, and the unit is hertz. What is the root mean square? The root mean square, or RMS for short, is the measure of a varying quantity. It is useful for working out the average value of a quantity that changes over time. And we can calculate it by this equation. Root mean square voltage equals 1 over root 2 times the peak voltage. And the short form is VRMS equals 1 over root 2 times V peak. This equation also applies for current. I RMS equals 1 over root 2 I peak. What is the average voltage or current? The average is all the measurements in one half cycle and can be calculated by this equation. Average voltage equals 2 over pi times peak voltage. And the short form is V average equals 2 over pi times V peak. Remember, the units for voltage are volts. And this also applies for current. I average equals 2 over pi times I peak. Now let's take a look at an example. Calculate the peak current given that the average current is 10 milliamps. We can start by writing down our equation. I average equals 2 over pi times I peak. To work out the current peak, there you can rearrange, and that would be pi over 2 times I average. And we can plug these values in. So pi is 3.14 over 2 times current, which is 10 milli. So that's 10 times 10 to the power minus 3. And that gives us a value of 0.0157 amps. Next, we can look at what a form factor is, which is the ratio of the root mean square to the average, and can be calculated by this equation. Form factor equals root mean square voltage divided by average voltage. And the short form is form factor equals VRMS divided by V average. And we can also apply this for current. The form factor equals I RMS divided by I average. Coming back to our form factor for voltage, if you remember V RMS, the equation, is equal to 1 over root 2 times V peak. And V average is equal to 2 over pi V peak. The V peaks will cancel, and we're left with 1 over root 2, and that's going to be divided by 2 divided by pi, which we can bring to the top, times by pi at the top, which is equal to pi over 2 root 2. And that's equal to a value of 1.11. Now let's look at an example. Calculate the root mean square voltage of a sinusoidal waveform given that the average voltage is 10 volts. We can start by writing down our equation. Form factor is equal to V RMS divided by V average. And we know this is equal to pi over 2 root 2, which is equal to 1.11 to 3 significant figures. And the question is asking for the root mean square voltage. So VRMS, so we're going to rearrange this equation. VRMS is equal to 1.11 times V average. And that would be 1.11 times 10, which is equal to 11.1 volts. How do sinusoidal waveforms compare to non-sinusoidal waveforms? Here is an example of a sinusoidal waveform. Non-sinusoidal waveforms are a square wave, triangle wave, and a sawtooth wave. There's many more, but these are the 3 that we need to know about. Square wave, as shown in the picture, is a wave that alternates between 2 voltages, typically high and low, with equal amounts of time spent at each level. It has sharp transitions between the 2 states. A triangle wave exhibits linear triangular oscillations between 2 voltage levels. The waveform slopes upwards and downwards with equal steepness. And a sawtooth wave has a linear rise and sudden drop, or vice versa, in voltage. It resembles the teeth of a saw, hence the name. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you.